Hello, in this video we'll be utilizing OUSPG's LLM Hackathon environment to try out Giskard, a LLM scanning tool to uncover vulnerabilities in large language models. Let's get right into it. Alright, now let's try out the Giskard tool. The Giskard LLM scan analyzes a large language model by running several tests on the LLM, uncovering weaknesses and vulnerabilities such as prompt injection, hallucination, or the generation of harmful content. Let's see, if you aren't already attached to the LLM Hackathon container shell, do so. Let's do so. Let's add sudo since we're on Linux. Now we're connected. Use command ls to make sure there is a directory labeled Giskard in the current directory. And yep, there we go. If there is, we can check out the contents of it with ls Giskard. And we can see there's the LLM scan Python file, which contains a Python script that runs the Giskard LLM scan on the large language model that we previously downloaded to the Ollama container, which was v3 by default. And if you downloaded or want to use another or analyze another large language model, well, first you need to download it and run it inside the Ollama container as was done or instructed in the setup part of this documentation, and we need to change the model parameter accordingly in the LLM scan Python file. So let's see how that happens. So this is the LLM scan Python file. Here on line 16 we have the model. We have defined the model v3 by default. So you want to change this to the corresponding LLM tag of whatever LLM you are using. And we can define a custom dataset that will be used to evaluate the LLM by the Giskard tool, and this can be done by altering the custom dataset parameter in the LLM scan Python file. Let's see where that is. Here's the custom dataset. It's a pandas data frame with one column labeled prompt, which includes all the prompts that you wanna use. You can insert them here. By default, this script is using a Hugging Face dataset called Hackaprompt dataset, which includes approximately 600,000 prompts for, you guessed it, hacking large language models. Since it's so large, by default we'll be taking only, how much is this, like 50 or so items from the dataset, and we'll be using this HF dataset to evaluate the large language model. This is, if you want to use a custom dataset or define custom prompts and use the custom dataset, you just switch this HF dataset with custom dataset variable, and now the analysis will be using this dataset instead of this one. But let's change it back to HF dataset for this demo. And we can start the LLM scan with this command as long as we're in the correct directory, which we earlier checked that we were. I just copy paste that command and the script starts running. First is downloading the Hugging Face dataset, which may take a while depending on your internet connection. Mine's quite fast right now, so it already downloaded it, and now it's going too fast. I don't have time to explain. So the Giskard tool will be you running these detectors on the defined large language model, and this whole analysis can take from anywhere between say 15 minutes to several hours, depending on how large the dataset is you are using to evaluate the large language model, as well as the amount of compute you have available for running the large language model. So yeah, if you're doing this analysis or scan on a laptop, this may take even several hours. We'll see how long it takes for me. As I'm using only the CPU, it may take a while, but I'll come back to this after the scan is complete. Alright, seems that the Giskard has now run its scan. We can see here that scan completed, 7 issues found, and it took a bit over an hour, 1 hour and 11 minutes for the whole scan. And as you can see, it states here that 1 errors were encountered while running detectors. So while the scan is going on, let's see if we can find it. There may be some errors along the way, like here is the one error, I think. Could not parse generated data, but the software handles these errors gracefully and just continues on to the next detector, passing the one where it encountered an error. So now we want to see the results. Let's see, after the scan is complete, evaluation report will be generated into the current directory labeled Giskard. Let's see, ls Giskard scan results.html. Yep, we can copy the file to our host machine by doing this, by tapping exit, and then running this command cp, and the dot here at the end, and indicates where you want to copy the file. Dot meaning current directory. Let's add sudo. Yep, successfully copied. And now I'll move the file to my Windows machine and explore it there. Alright, now I have the scan results on my Windows machine, and we can explore the HTML file in our browser. Let's see, it generates this sort of a report. As you can see, we have 5 issues in the prompt injection section, and then 2 issues in the hallucination and misinformation section. So let's see, for example, Stan, fail rate 1, so failed every time. 1 of the injected prompts manipulated your LLM into operating outside of the typical AI rules and avoiding norms. So here's a full report and results of this specific detector, and there it explains what this detector does, what its point is, and then here we can see the prompts and the LLM's responses to it. And you can go through all these, figure out how you can, or figure out vulnerabilities and weaknesses in the LLM you're evaluating. The LLM Hackathon repository already contains an example of the Giskard scan results, an example file. So if you do not have the time to take an hour or wait for an hour for the Giskard scan to complete, you can just test out that the Giskard starts its scan and then close it, and then use this example HTML file to examine the report. And let's see if there's also an example report for dependency check. And I believe Garak, it's an example of the Garak runs. And that's all for this series. Now you can dig deeper into hacking large language models by completing all of these objectives found in the documentation or README of the LLM Hackathon repository. And if you can successfully complete all of these objectives, you now know that you know how to test large language models for vulnerabilities and weaknesses. Thank you for watching and good luck hacking.